Okay, so you just follow along, okay? So in this case, it's 84 times 36. That's 3,024 inches. Because 1 yard, that's 3 feet, right? So hence 36 inches. Calculate the surface area of a cylinder. So surface area, I hope you have those formulas. That's 2 pi r squared plus 2 pi rh. And so I'm just going to go r squared would be 25 times 2 is 50. So 50 times pi plus 2 times pi times 5 times 8. So I add those two up. 408.41. And we are in centimeters, right? So centimeters squared. Are we good so far? State the y-intercept for this function. This function is a linear, it's a polynomial. How do you know it's polynomial? Because you've got like a plus and then just an x or an x squared, whatever that would be. So in this case, the y-intercept is just 0, 3. Or you can graph it, right, if you want to. What's the x-intercept? Turn off plot 1, right? Remember that? So you go 5 divided by 4, and then x plus 3. You graph it. I'm going to do a zoom standard here. There it is. So second trace, no. y2 is equal to 0. Second trace 5. I know that some of you can do it algebraically. In this case, it's 2.4, negative 2.40, okay? That's all I need there. State the number of possible x-intercepts for a quadratic function. Possible is 2, right? The number of possible, it doesn't say max, so I would say 0, 1, or 2. That's very unique to quadratics, all right? 0, 1, or 2. A cubic has a minimum of 1, right? A cubic will always cross the x-axis no matter what. But a quadratic has the 0, 1, or the 2. Maximum number of x-intercepts for a cubic function would be 3. What determines that, by the way? The maximum number? It's determined by the degree of the function. So a cubic has a degree of 3, so the maximum is 3. A quadratic has a 2, maximum of 2, right? So if they ask for maximum, that's how you know. The end behavior for a cubic with a negative leading coefficient, right? So it's the same as a linear. So it would start here and then end up there. So it would be Q2 to Q4 if it's negative. Number of turns for a function with a degree of 2, there's 1 turn, right? It's either a turn there at that point at the vertex or a turn there. So it's 1. If a quadratic function has a minimum of this, state the range. When it's a minimum and it gives you a coordinate, that is the vertex. Okay, so that means that this thing is pointing up because that's the only way to have a minimum. So we are particularly interested in that y value of the coordinate. So in this case, y is greater than or equal to 12.5 is one acceptable way of doing that, or 12.5 to infinity, round brackets, square brackets. It's not a word problem, right? So state the domain for the previous using set notation. What's the domain of a quadratic without a word problem? All real numbers, or negative infinity to positive infinity. Okay. State the equation of the asymptote for a logarithmic. Right, that's x is equal to 0, right? Question, yeah? For domain, yes. Even if, like, I'm running out of space here, but regardless of which way it's pointing, these will open up indefinitely to both sides. Yeah, does that make sense? Okay, ask anytime, okay? Logarithmic, the asymptote is along along the y-axis, right? And this one is a little unconventional because we know normally, I just need you to be comfortable with that. Log x. A in this case is 0. You got to make a note of that. A is equal to 0 in this case. So 1, 0, technically that's your x-intercept right there. If b is negative, it's going to go like this. Okay. Anyways, that's overkill. The asymptote is x is equal to 0. That is the equation of the asymptote right here. Okay. What criteria must be true in order for a logarithmic to be increasing? I would always say when it's a question like this, it's a good idea to state the general form like this, and you would just say b has to be greater than 0. Okay, when it's logarithmic, if this value is positive, you've got an increasing function. When graphing the logarithmic, this one I told you to scratch, right? But I'll never be able to tell you this again once you're out and graduated. So if it's log, the base is 10. If it's natural log, the base is e, 2.71, and it keeps going. But I told you not to do it, so you don't have to worry about it. And it's not stuff that you need to know for the exam, so that's fine. State the domain for this one right here. And we know that this is your asymptote here. And this is, b is positive. So we're having something like this here. And so the domain would be x is greater than 0, like that. Not greater than or equal to, just greater than. Or you can also say 0, from 0, almost 0, to infinity, like that. Either one is fine. Explain what the growth factor ratio means in this equation. The growth factor range is 0, right? B is 0.59. So that means that we're decreasing, right? It's a decreasing function, so it's 1 minus 0.59. What is that? 0.41, right? 0.41 or 41% decrease. Anybody else? Were you wondering what this is saying? Yeah.
What's the base for ln?
For ln is e. Yes. Go ahead.
What's the, like for question 12, what's the difference between like b being greater than 1 or 0? Because it says that in the text or in the book it says that 1.
Are you sure it's bigger than 1?
Yeah, in this book it says 1, increasing greater than 1.
Okay, I'm gonna check before I answer that, because if it is, because b greater than 0 is positive, right? It's a positive. If it's greater than 1, it's like it's greater than 1. I'm gonna check, because if where is log? 30 something? Yeah, there it is. 33, right? For logarithmics, it's bigger than 0
Okay.
and less than 0, so positive, negative. For exponential,
What would it mean? Oh, for exponential as well?
it's 1.
Okay, that's what I was confused.
Good questions. Because I'm sure someone else was thinking it as well. Let's go to I'm just going to show you. Sorry, YouTube world. I'm a little, it's a little messy here today. Yeah. So with an exponential, if this is 0, we're out of business. Like we can't have that being 0, but you can have it being greater than 1, or this being between 0 and 1, like you have a decimal. that it's 0 point something. Okay. Does that make sense? So make sure your study sheet has that too, okay? Any other questions? Look alive, guys. It's Friday. State the end behavior of for this function, the end behavior. There's no word problem around it, so we can say, what is this, exponential, correct? Because x is the exponent, so it's decreasing like this, but it doesn't really matter. It's q2 to q1 regardless. Even if it had been increasing, it would still have q2 to q1, so that's unique to this one. State the y-intercept. The y-intercept is simply the letter A, right? So 0, 400 is the y-intercept. Now, of course, you can use your calculator, but I think that would take a lot of time. State the equation of the asymptote of this the above function. The asymptote is running alongside the x-axis. So it's what? Y is equal to, right? Y equals to a number is always going to be a horizontal line. And you want it to be 0. You want to be right on the x-axis. That's when y is equal to 0. So if you want to make a little note, I would keep this one. This is a really good review in general. State the range of this above, the function above. So you could do set notation where y is greater than 0, not equal to, okay? Or you can go almost 0 to infinity, right? It almost touches 0, but never quite does. And it goes up to infinity positive. If the above function represents an investment, what would the range be? Oh, I think I made a mistake there, right? You're saying yes? Well, it's a little unfair that I'm mixing it up, because when I state this, I'm assuming there is no word problem associated with it. All of a sudden, I throw in a word problem, that this is an investment. So technically, when it's an investment, we're only carrying like, that's the 0, 400, right? That's our y-intercept. And the investment is going down from there. Okay. But it's never going to touch. So what would be my range here? The lowest I can ever get to, according to this, is almost 0. And the highest I ever get to is 400. Because I introduced this scenario here. You could also say that y is between 0 and 400, 400 inclusive, okay? 0 has just the opening there. So that's not a good investment, is it? Your money's going down. That would be a sad. Okay, next page. So now we're switching gears. We're doing odds, right? Odds for, so in favor of selecting a face card. So you want face cards and compare it to non-face cards. So we've got 12 to 40. Right? How do I get the 40? I go 52 minus the 12, and that's how I got my 40 there. And again, I want odds against a diamond. So if it's against diamond, then you want not diamonds first and then the diamonds next. And I tend to focus on the positive in life, right? So how many diamonds do you have? Let's go for what we have, 13, right? And how many are non-diamonds? 39, right? Because I go 52 minus 13 to get the 39. 52 minus 13 to give me the 39. Determine the probability of selecting the 6 of diamonds. How many 6 of diamonds are there? There's only one. Out of 52. That's where you get probability, so you get to put the total in. Can I just draw your attention? How do you know you're probably right when you do one of these? They add up to 52 every time, right? They add up to my total possible choices. Probability of not picking a 10. How many 10s are there? There are 4. So I will go 52 minus 4 out of 52, right? So that means that it's 48 out of 52. The probability of not picking a 10 would be 48 out of 52. The probability of selecting a 6 or a diamond. What are we? 52. How many 6s? And how many diamonds? Yeah. There's an overlap. Almost fell for it, but I have students that are paying attention. So yeah, so let's do this again. There are 4 6s, right, and 13 diamonds, and I have to subtract the 6 of diamond, right? 6 of diamonds. I don't want to double count that one. So this will be 17 minus 1 is 16 out of 52. And that's why we're doing it this way. Determine the probability of selecting 2 diamonds when selecting 2 cards without replacement. Okay? I want you to, there are 2 ways of doing this. Okay? If it's 2 of the same, I taught you to do it this way. How many diamonds the first time around? 13 out of 52, right? And how many diamonds are there for the second draw? 12. And I only have 51 cards left, right? So you multiply that out and you get your answer. Let's get that. 13 times 12. That's 156 over 26, 52. And you know how to reduce this, right? 1 over 17. Okay? Or, watch this here. You can use combinations. Shh, pay attention, guys. You can use combinations. Out of 13 diamonds, we're going to choose 2. And out of the 52 cards, we're going to choose 2 as well. 13, do you remember how to type this in? You should probably go and check it out. It's alpha window, right? To get choose. 13 choose 2 is 78. And 52 choose 2 is 1326. And you're like, they're not the same. You got to either turn them into a decimal or reduce them. Oops, math. There it is, 1 over 17. So you can use either method. This is the most common one. If you have the same cards, and this is probably the way to do it. Okay, this is basically 2 diamonds, one after the other without replacement. What do we call without replacement? What kind of events are those? There's a difference between independent and dependent. So these are dependent. What do we call, like when this happened here, like the 6 or a diamond, there's mutually inclusive and mutually exclusive, right? Are these ones mutually exclusive, these events? And you would say no, because they have an overlap, right? So we can say these are non-mutually exclusive, okay, these events here. Determine the probability of selecting 2 face cards when selecting 2 cards with replacement. So face cards, we've got 12 out of 52. We replaced that one, so we're back to 12 out of 52. So we just multiply, that's 144 over 52, that's 2704. I know you can reduce that, but I'm just gonna leave it at that. In the previous example, is that an independent or dependent event? You'd say independent due to replacement. Okay, there we go. All right, let's do the Venn diagram. NU is all of it. What is it? Okay, you're gonna save me time. Did anybody else get 47? Are we getting 47 for the total? Okay, I'm just gonna go with the flow here. 47, thank you. So 47. So you add up all these numbers, including the outlier, right? N of A. I can do this one maybe. 9, 11, 19, yes. So it's 19. You got to go all the whole circle. B union C. I will highlight this one. B union C, it literally wants all of this. Whatever is in that union. What is it? 34? Do we get 34? Anybody 34? I feel like this is like an auction. 34, anyone 34, 34. What is this one? Do you remember this one? B but not C. So you want B, but you do not want C. So it's just this part right here. This one is B but not C. Okay, it's that half moon there. So it would be 15, correct? So it's 10 and 5. Not B. The easiest way to do knots, I will find B. This is 13, 15, 20. B is 20. So I'm just going to go total minus 20. I'm in trouble there. I just realized it. Sorry. I'm doing this key with you. Do you notice something? Probability. So I need to have the total down here. And not B, now I'm going to do the not B. 47 minus the 20. 27 over 47. Okay? We're good? C intersect A. What is intersect? We just want the intersection, right, of the two. C not A. So how do we do this one? C, so not A. C and A would be this here, but you don't want A. So is that a null set? C and A would be here, but C, I think I just found it. C and A would be here, but you're saying not A. So obviously this has to go. I'm stomped on that one. I was going to say this one here, but no. Beats me. I'll have to think about that one. I'm in too much pressure right now to do that one. So 47, union A, union B. It's these two, the union of those. What is that? 32? If you, so this is 12, 14, 19, sorry, 12, 14, 19, 22, 32. Yes, you got that one. Question, did anybody get help on 34? Did anybody talk to a smarter teacher and figure that one out? You did? What is it? 9?
No, like 9 out of 47.
9 out of 47? How did you get the 9? Did you just add this?
Whoa.
I have to think on that one. Because to me the intersection would be... But that would make the most sense right now to me, to go 6 and 3. So you made 9 out of 47. But you don't lose marks on this one until I figure it out. I'll go talk to her. Okay, 9 out of 47. Okay. 36. How many ways could the coach arrange the players for the photo? So you've got 8 girls, 3 boys, so that's 11 total. How many ways could the coach arrange the players for the photo? That would be 11, pick 11, or 11 factorial, right? I'll just leave it at that. How many ways could the coach arrange the players if the boys were together? This one is, I'm still a little confused why a lot of you are getting this one wrong, so I'll actually take the time here. So for this one, you've got 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This group of 3 moves around, right? Anywhere. So that's 3 factorial. So your answer is 3 factorial to start, but then you count this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it should be 3 factorial times 9 factorial to get that one right. And it just says how many ways, so we just leave it like that. How many ways could the coach pick 5 players for the starting lineup? Perms or coms? Coms, because there's no specific role, specific position. You're not arranging them. You're just selecting 5. So you would go 11, choose 5. That's it. I don't know the answer right now, so 11, choose 5. I'll trust you in getting that right answer. How many players could you pick if 3 girls and 2 boys have to be there for the starting lineup? Well, now you're splitting it up. So from 8, you choose 3. And from the 3, choose 2. 8, 3, choose 2. You multiply that and you get the answer there. What is the probability that the entire starting lineup is girls? So you want no boys, right? In a sense. So I will go, what's the total here? 11, choose 5, correct? That's all possible teams. And yeah, in a bit. And so just girls, so that would mean 8, choose 5, correct? And if you want to, I don't mind you doing this. From the 3, you choose 0, but that's just 1, okay? So what do we have for the bottom, Leah? What did you get? 462. And the top? Okay, good enough. So we'll just make everything worth 1 mark. It'll just make it a little easier, except for 34. We're just going to make this out of 39. Out of 39. What's that? Oh yeah. And 13, the base, we're getting rid of that. So 38 total because of 13. Okay.